Here we are again. This is now video number
And we're
4.
back. Video 4, where we tackle the initial and hardcore setup that is trigger, the mysterious trigger setup. Now, depending on what ECU you have, and I actually defer to you, what are we going to start with? The easy stuff?
You know,
The popular stuff?
the thing is that
I think
okay,
it's the easy and
you
popular.
know we can make a really I'll throw you on a little loop here. Can you think of an ECU company that does a really good job of even if you lose trigger sync, it still runs almost all RPM? Can you think of one? So I can think of
Well,
two of them, and they
there's
kind
well, obviously,
of
Haltech has an option where if you set it up, you can ignore the cam sensor. But I don't know of any other ones
so
that can do it.
so from experience, Link, okay, Link is very good at this. Mtron is very good at this. Um, if it loses trigger sync, and
Now,
instead of it being a
when you say losing trigger sync, let's be specific. Is the cam sensor going away, or is the crank sensor going away?
right, so on the ECU, it's going to either show a trigger or your home or your crank or your
Remember, trigger is crank, home is cam.
right. Thank you.
So if you want to generalize it, we can stick to crank and sync.
Right. I say crank and sync. So you'll see either on these ECUs a trigger loss, which is the RPM of the engine, or you'll see a sync loss, which is the location in which it's starting as a reference point to the top dead center of this engine. And what I have found personally is let's say we have in a very specific application that many of you might be familiar with, an FFE trigger wheel that is a magnet sensor VR with its voltage off, a certain trigger voltage for filtering. If that sensor is too far away, let's say 80 thousandths of an inch, when it should be closer to 20 thousandths of an inch, that will have the effect of sometimes losing the sync of the engine. In this case, it's actually losing the trigger. It's the number of rotations that's happening. And instead of completely shutting the engine down and realizing what it is, it has a memory of what it did prior, given that same situation. And it limits the engine, kind of like throws a little bit more retard in it, adds fuel. Very smart system. And I don't think it's even adjustable. It just kind of does it. So Link does that. Fuel Tech does an interesting thing where it kind of has like a phantom RPM that changes all over the place. I've seen it go 5, 6, 7,000 RPM. Similar thing. All these ECU companies have something, I think, maybe Microtech doesn't, but something to the point of when it loses the trigger identification, which we will explain very shortly, it gets upset and usually will know how to correct the motor without creating an issue of failure. You know, losing the location of an engine, that's the most dangerous thing imaginable. So that's why we have to be so critical about how we do this. And when we go to set things up, both mechanically and digitally on the software, we have to be thorough in our setup where, for whatever it is, in any situation, it never loses location of the engine and the RPM of the engine. That's going to be what kills engines.
And another thing to add there is if we think about the behavior of an ECU when it does in fact lose, let's say, crank. Now we got to be a little bit careful here because rotaries can get away with one trigger or one signal, unless of course we're talking second gen or third gen, which we have a 12 plus 1 scenario. But if we've got an RX8 trigger where we're talking only one signal that is giving it all the information it needs. If that signal goes away, normally the behavior of the ECU is, well, I've lost sync for X amount of time, or let's call it time. And what it usually does is say, well, engine's off. And in that very, very tiny amount of time that actually passes for us mere humans, for an ECU, obviously it's a very monumental amount of time, since we're talking nanoseconds. Um, what it just says is, well, hey, the signal's back. The engine must have restarted. And it very quickly will go through its cranking and startup parameters again. And that is usually what will cause the issues, which will make the engine just grenade. So we got to make a very, very, let's say, key point there, that so that people understand why does the engine break, what happened. But if we keep the the crank trigger signal from going away ever, then obviously we should not run into this kind of situation.
The thing that I see more common than not, what kills the trigger, either crank or cam, is usually EMI related. So this is an electrical magnetic interference of something affecting on the car that shouldn't be. This could be like an ignition coil with a spark plug wire that has failed. That's something that has an infinite resistance. The coil has to fire into something, and it creates enough EMI. Actually, I have a gauge right up behind me, right above my head, right there. That's an EMI gauge right next to those yo-yos. That is designed to identify EMI on a harness, EMI on a chassis. You walk it around, you kind of pinpoint these things. I'll have a car where it revs, and let's say it was an Adaptronic. I have this screenshot on my page, by the way. I'll show this to you guys later. Um, it goes to negative 4,000 RPM. Well, Claudio, what is negative 4,000 RPM for a given ECU? We have no idea, right? And to the point of EMI affecting an ECU, sometimes it'll hit new unobtainium cells on fuel and ignition mapping, or throw in some random numbers that just causes the event. So even if it's not a restart causing the event, it could also be an EMI triggering the ECU to something where it's hitting a new region that's untuned or couldn't even be accessed from its unit.
It effectively screws up its math.
Yeah.
Pure and simple.
Yeah.
One really awesome analogy that I got once out of a seminar was, the instructor actually referred to the computer as a forward working calculator. It can't guess. It can't work backwards. It's constantly moving forward. So if it's, for example, going in one direction, obviously the engine spins in one direction, it's counting upwards, and all of a sudden it gets hit with EMI, or a coil arc in the grounding system just went berserk, and it basically makes it get jump data. It's going to say, well, I was over there, and then I'll have to be back here again. No, hang on. So when those kind of things happen, what I've seen in the past is the ECU sort of tends to freak out in a good way, because it'll stop working. And you can see this in, for example, if you've got a simulator, like, I'm doing some more show and tell again. If you've got a simulator like one of these guys, yeah. So if you got one of these, you see all the injectors pulsing, and then all of a sudden you're only seeing a couple pulse, and it doesn't finish the whole sequence. So that usually tells you something is funky in the setup, something is making the ECU upset past a certain point, and of course it stops working from there and says, well, I'll wait for the next clean turn or the next clean sync. Sometimes it just stays in that loop. So all of this definitely can be prevented if you take care of your settings from the get-go. Scope your signals, try to get the engine to rev high enough and see where they go. If there's an issue where your cleaning parameters, your filtering, your arming voltages are not covering what's going on, then of course the ECU is going to stop and expect or wait for the next clean signal.
And to add to that, what's really cool is we have so much technology coming into these cars from different, I would say like different sources, right? Um, Instead of going with a VR sensor for your crank trigger, well, you can go Hall effect.
I like
And
VR.
now we're talking, we already have our own dedicated power to it. We have our signal ground dedicated to it, and everything is going to operate in a different manner. And the things are being developed at such a high level throughout every industry that the trickle down effect is all of these good sensors are now cheap, at least relatively cheap. So you're getting so much more for your dollar, and that's a safety factor of saying, I spent this much on sensors, but I now know so much more about the car.
Key point. Key point. Don't buy cheap knockoff crap. There are loads of colleagues of ours showing why you shouldn't buy cheap knockoff crap. It's worse than using splicing wire and electrical tape and butt tape. It's worse than that.
You're telling me you
Uh,
don't strip two wires and you just put a zip tie and hold them together?
no. Hey, I'll tell you what though. I'm going to say it as a joke, but I'm going to say it because we're young sometimes and we're inexperienced sometimes, or we lack the resources for proper tools. I used to put terminals with this thing when I was a kid.
Now you use it for nose hairs, right?
Well, I use it for pinching the shrink on my splices and making it
Oh,
nicer.
so it's a beautification process at the end of his work. That's actually really
Yeah,
cool.
yeah, yeah. I don't have anything right now that I can show. But anyway,
But anyways,
so
enough show and tell. We're gonna get started
yeah,
with what we got here.
yeah. So let's talk about trigger today. Let me just
Yeah,
share
do
my
you want a
screen
screen
real.
share? Does that work for you?
I will try that. Bear with me if you want. Let's discuss some of the trigger types we know and love.
Should I just jump in?
Yeah, 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 go ahead. I mean, if you want,
Oh,
let's talk about the different trigger
th-
types.
this is your bag, my friend.
Okay. Hang on. I'm gonna have a little trouble
So
here.
there's like,
I'm
okay,
on the run.
to find something that is a cam and a crank, you can have a full constant connection as far as the way that it's reading. So it will have, let's say we have a number of teeth on a wheel. That could be a constant number. And then we have another object that's a constant number. And because it knows this is the number here, this is the number here, it works. Then sometimes you have a singular wheel that has the function of doing both jobs. That is both engine speed and engine location. That would be something like a missing tooth no home or a missing tooth single home or something like that. And that will be, let's say we have a 60 minus 2 trigger wheel from a GM or like aftermarket electromotive, something like that. That means that there's going to be a wheel that could have had 60 identically heightened and width teeth, but two of those are missing. So now you only have a 58 total tooth trigger wheel. And because that -2 location on this wheel are, we know where they are based on our top dead center, we've defined that as our top dead center. Um, that now gives us, thank you, Claudio, that now gives us a dead point for our zero location. So now we have
Okay.
both our trigger
So
and our sync, one wheel.
exactly. So one wheel, you've got a total of 36 teeth minus one missing. This would be a typical Ford engine or some Mazdas, or it's one of the most popular universal options to get. So the missing window, the missing tooth window, basically just helps the ECU determine where TDC is in combination with the settings in the software, which we'll look at in a few. So the alternative is, of course, no missing teeth. And then on top of this, we also need a CAM event or CAM signal that will let the ECU complete the sync or effectively just say, hey, TDC is coming up. Now, the way I like to think about crank and cam, and especially the cam, is the ECU needs to know, first and foremost, where the engine is in the rotation. Now, in order for it to know when TDC for cylinder 1 is, then it needs the cam position. And if you normally look at an engine, since we think of the ECU as a forward working calculator, you have to warn it ahead of time when TDC is coming so that it can effectively do its calculations promptly. So for example, if you put the motor at TDC, usually what you'll see is the cam event has passed the sensor already by X amount of degrees. So what that means in the reverse is if you line up the cam sensor with the tooth or the event, now you're X amount of degrees before top dead center. And this is usually the value we call either TDC offset or trigger angle or something along those lines, where it basically tells the ECU, hey, the TDC is coming 70 degrees from now. Or it works it out in teeth, or depending on how the software is written. There's a few alternatives here and there. And as obviously ECUs evolve, manufacturers tend to switch it up or make it a little bit more intuitive, and so on and so forth.
Right. I'm actually pulling up Link, Haltech, Adaptronic. All these ECUs will do it a certain way. But it's more so the information is always going to be there. It's how you interpret how to find it and how they say it differently. It might be terminology, and you can kind of say this software is just a different terminology with the same language. That's really kind of the best way to explain different ECUs is they're trying to do, at least for the most part, something very similar.
They're all trying to do the same thing eventually. Read engine position, read all the temperature sensors so they can calculate air density and all that other stuff, read throttle position, and based on all the sensors, the ECU will be programmed to put X amount of degrees of spark timing and X amount of pulse injector pulse width so that we can match the volume of air going in the motor at any given point.
Mhm.
All right, so I'll tell you what, while you look at that up, so let's just run down a quick explanation of what our basic crank and cam sensors are. There's basically three. We've got our VR sensors, or magnetic resistive, which is basically, if you look at them in an oscilloscope, what you would see is a sine wave that goes up and down, and this is a voltage variation. When a tooth passes the sensor, each time it changes the voltage that's going through, or the resistance that's going through the sensor as a tooth goes by. Normally, these sensors read metal or ferrous metal teeth. That way they react. If you had an aluminum tooth wheel, then it wouldn't react.
Same goes for powder coating. You cannot be powder coating a trigger wheel because it will stop the effectiveness of the trigger wheel.
Unless, of course, you polish up the edge of it or something along
Yeah.
that line.
So,
but anyway,
it's just a forewarning for people that like to powder coat things that aren't supposed to be.
And also the guys who powder coat the chassis, they put a bolt in it for a ground, but they didn't clear the paint off so that it makes proper contact. That also hurts your grounding. The next type of sensor we have are Hall effects. These sensors are typically recognized by their three wires. They'll have a signal ground, a signal for the sensor itself, and a power, either a 5, 8, or 12 volt signal or power supply. There's optical, which are the same as Hall, but work in a slightly different way. They have a disc that is basically read by a sensor, and every time there's a slot going in front of the sensor, you get a pulse from the sensor. You see these on Mitsubishis, the older Mitsubishis. You see these on Nissans, the RBs, the old SR20s, and so on and forth. That those 90s and 80s cars. They're not as popular these days, but you see them every once in a while. And then that's your basic three. And then depending on what you have, you must set some filtering and arbing voltages up so that the ECU reads them properly. We can actually bring up some examples of that.
Yeah, I'm getting them all right now. So I was debating if I do 4 screens at once and show you guys that way, but it's a little bit
Just
too much.
do one
So
window at a time, I guess.
yeah. So if we go here, I mean, I'll try to make this not too complex here. So let's go share screen. We're gonna share. Let's go to this one first. This is pretty easy. So on this Adaptronic right here, this is a base map from them, which was funny enough, actually done incorrectly. This was supposed to be, if we look here, this.
Why don't we do a relevant system that's available today?
You don't like the ones that are out of, okay, well, this one's out of stock.
Hey.
It kept having ignition board problems and all sorts.
We could talk about E6K if anybody wants.
Okay, hold on. So find another one. Thanks, Claudia. That was a nice example.
I just throw up a link. A link is a nice one.
I have link here, but it's a very odd one. So
just grab a basement.
Well,
one of the basements.
It's fine. It's fine. Here we go. And we're gonna share the link one right here. Okay, so this one's a little bit odd. Okay, the reason this one's odd is when you go to set base timing, normally this value is not acting as if it would be, on this case, a rear rotor. So the TDC that it was picking up here was finding our TDC to be 268 degrees off of original timing. And we would set this by, we're locking our timing at TDC or whichever is easiest to reference for our given time and light configuration or crank marking positions. And then if we have, let's say we have a different ignition style, sometimes we can offset the delay in our ignition timing constant, which will affect the RPM change, what do you call that? Like walk of the ignition delay. So if we have our timing set at 0 degrees on this ignition lock right here, and we hold the engine up at 1,000 RPM increments, and we see that it's changing the ignition timing in a curve. So instead of it staying at 0 and 0 and 0 and 0, it might be advancing the ignition or retarding the ignition. And we would change this delay here to correct that.
But what engine is this, though?
This specifically is a 13B REW.
With what kind of a trigger?
This is a Hall effect. Let's take a look here. It should be
FFE?
FFE trigger wheel, 36 minus 1.
That's why it's so oddball, because the way they do it is pretty much the same as the Haltech, the -5, -7 degrees. I guess one of the key points to make here about Link is the way they have their offset, their trigger angle offset, is they have a plus or minus 360. So they start from the middle. So in the case of running, let's say if you're comparing it to a Haltech, on a rotary, for example, the value that you said is either around -5 degrees, and the reason for that is that's -5 BTDC.
Right. Before top dead center.
Exactly. So instead of the value, let's say for argument's sake, the event doesn't happen at 0, it happens 5 degrees before. If you are doing, let's say, some other engine, your value could be the plus 50 degrees, minus 50 degrees, whatever it takes to sync it. So
Right.
what they do is they allow you to start from a middle point and either work your way forward or work your way back. It's basically the 720 degrees that you would see on most other brands.
Right. So the
But they
reason,
started from the middle.
right, the reason why this one's 268 is it's acting as if the top dead center would be off of the rear rotor. Um, Sometimes all these are shifted around on link. I have found there's never really a consistent value. Like on most Haltech, Adaptronic, let's say any other platform that I've found, they're normally within about a 3 to 5 degree variance of what that base mapping would be configured as. For whatever reason on this ECU, like Claudia was saying, it's almost like a floating bounding. But 107, or I'm sorry, 270 degrees is 180 degrees plus 90. And if we look at the FFE trigger wheel manual on it, REW, it's going to be starting at 90 degrees offset BTDC. So that's why it's 90 plus the 180 degrees to make it rear rotor. That makes sense. So
I
that's
mean,
why this one's close to 270, which would be 90 plus 180.
or probably dumbing it down a little bit. Basically, they've clocked the wheel as they build the kit in an oddball place. This
Yeah.
is why usually it doesn't matter where your crank and cam sensor combination or position is, you can technically always figure it out if you tell the ECU don't move, stay at this timing value, let's say 0 degrees, if that's the only one you have to work with, and then you just play with the timing offset up or down to get it to line up
Yep.
using a timing link.
And what I wanted to show here was all of these ECUs will have these huge lists of integrated, what they have already predefined for you as an optimized trigger setup. Now, I think Altec does a really good job at this. They go
They've
through,
got a wizard now. Did you see it?
they do. Go for
Yeah.
it. You want to have it
Well, I
on your
mean,
side?
well,
So
yeah,
you can go
okay.
here. This is actually the way to choose
Yeah.
it the right way.
You just
So,
find your engine, boom.
yeah. So what's interesting here is this trigger type on this is just a forewarning. If I were to change this, let's say just random number here, it doesn't actually change these values. See, it
Right.
creates an error, but it doesn't actually change the values. So it just created an error for itself. If I instead grab that same thing over here inside of that trigger system wizard, it populates the whole thing. And then you can show your settings for that. And so the TDC angle for this engine, being it's a reciprocating 4G63, is 435 degrees. That's where you're going to be finding your zero reference point or whatever they're trying to reference for when you lock the ignition timing. So what we're trying to tell you is that all of this is relevant to your setup, but every setup is going to have its own nuances that you need to understand. And so we're just trying to explain the basics so you can figure that out for yourself and then move forward with the actual tuning process.
Yeah. Now, if let me jump in on the Haltech here a little bit. So,
Would you like that back up?
I'll put it on my end this time.
Awesome.
Okay. So where? Bear with me. There
I
it
know
is.
it's trickier than I thought.
Come on. It's just slow. There it goes. Why does it disappear? Hang on a second. Oh, I know because I got two of them.
Aha.
Bear with me. Okay.
By the way, while he's doing that, this is what I was talking about for EMF testing. So it's a little handheld dude. The guy who actually showed this to me was John Swide of Legend Motorsports. He brought this to a dyno day, and this was like the lifesaver of the day. Um, I had assumed, and I was actually right in assuming, that a spark plug wire had failed in this engine. It was acting like that. It was really odd. And I was like, huh, okay, what can we do about this? And the spark plug coils were in a very weird location for it. Um, it was freezing cold out there, and I don't think any of us had spare spark plug wires. We pulled that car off dyno, but ended up being crazy high EMF, and this guy right here found it. So it's a great diagnostic tool. Gets you out of trouble for sure. Go for it.
Yeah, hang on, my thing is being a bit pesky.
And we're trying to be really smart with the timing of these videos. I'm not sure if you guys realize that. We're currently using Zoom. Um, so please let us know if you like this style format. Um, they do limit us on the timeline for the or for the videos, so we're trying to make this informative, but not too unpalatable. It's a little tough.
Yeah, the counter says we got 8 minutes left.
I was just making sure you see it.
Okay, my thing is just misbehaving.
I know. That's, and like I said, it's more difficult than it looks. Um, what would you like to cover else on that trigger plan? Is there anything else that you had in mind?
Yeah. I'm trying to get to the thing. Hold on a second.
So in our
Sorry
notes,
about.
we had,
Yeah, here we go. Let's see if I can get it up.
I can pause this and be right back. You want?
No, I think I got it. Hang on.
Okay.
16 window. Here we go. See if it works now. Okay.
Nice.
Okay.
There we are. Perfect
right.
base map.
So, all right. So yeah, the generic one. That's
Perfect
an
base map.
interesting segue. So effectively, this thing will start any engine. You don't have to worry about it. It's enough fuel to just get it idling. And so is that ignition timing map that they got on here. That'll be enough to get any engine going. Effectively, you'll have to lock the timing anyway in order for all your basic setups to be done correctly. That way the engine doesn't move and you're sure that the timing between the ECU and the engine is correct. But what I wanted to go over briefly is just to touch up a little bit of what Ryan said about you've got your wizard that can let you select all the engines. Now, one of the other cool things that you can do is if you, for example, select an engine type, even though this is showing me an error that I honestly don't want it to do.
Well, when they updated this firmware, they made a reverse switch error for whatever reason. So that's always going to pop up on the new 10.3.
Yeah, but I don't want it to be that way. And then it's just complaining about cylinders. Let's just fix all that. Just check whatever's red. The ECU will let you know.
8-cylinder rotary.
Yeah,
I like it.
All these little quirks need to be addressed.
You should have started with the rotary base map.
Yeah, just anyway,
right.
we're back. So we're back. So one of the nice things about this software is that they've updated a little blurb that just explains what the crank and cam pattern is, what teeth you're getting. So this, combined with the use of the oscilloscope, can let you very easily verify if your ECU is correctly detecting or reading the signals. Now, one thing to point out, for example, it can be so helpful. Let's say you've got your engine idling and you've got a slight hiccup that you can't quite trace, but you see a bit of a blip in the diagnostics tab where the trigger sync level message and trigger sync state message don't stay put at running and full, which are basically the indicator that the ECU is syncing properly. So what you can do is if you monitor your oscilloscope, you can probably immediately tell that there's a problem with, let's say, the setup itself. And one example that I can name, which was saved by using the oscilloscope, is we were having a blip in the trigger, and there was a blip in the motor. You could hear it audibly. And then once we looked at the scope, we were seeing an interesting little peak that was popping up, a 13th tooth. if you will. And on a rotary, you guys know it's basically 12 plus 1. So once we stopped the motor and we looked at the trigger wheel, and effectively we saw that there was a dent in the disc that reads the tooth, and this was popping up as a tooth because it was going near enough the sensor that it was being picked up. So it's
So
critical to use the thing properly to be able to troubleshoot. It's invaluable.
So just to clarify for those who don't know what that trigger wheel looks like, which I'm sure Claudio can pull up, it is a
I'll find a
round
picture.
circular piece. There are 12 windows equally sized around them that are kind of like rectangular circles. And then there's a singular point standing upward. That's your actual 1 point. The windows are your 12 points. There's 12 identical windows. And then for us as owners and tuners, there's a small triangular cut put in at 20 degrees ATDC that we use a reference angle off of the front cover to know the actual location of the engine. So our job, of course, is once he pops it up there we go. So these right here, we've got 12 identical rectangular windows. And then we've got our one little nub sticking out. That's our 1 point, right? That's our sync. And these 12 points are our trigger. Right, Claudio?
Yeah. So these 12. Can you see my mouse move on there?
Yep. Yeah. So those
Okay.
12
So these
are our
these
trigger.
vertical ones, and this single one is the sync. And then this little V notch over here is our 20-degree after TDC mark. One important note, whenever you're working on an engine, if you don't have any timing marks, or if you're unsure that the crank pulley you've got is properly clocked to where the marks are lining up to the pointers, make sure you confirm this, because you can have, let's say, an incorrect trigger wheel or an incorrect crank pulley with marks on it, and you could be X amount of degrees one way, X amount of degrees the other, and you wouldn't know it. You're timing the motor and you're putting values in the software, and all of a sudden the engine grabs a lower note or a higher note, or it's fast revving, or it's just really boggy. And it's because you're not properly synced. So watch out for that.
I have a perfect story for that, and we only have like a minute left, but there's an engine builder that I know that's notorious for not setting top dead center for his engines. He'll take off a pulley that came with the engine originally from Mazda, and he'll swap on another pulley that he knows is like, we'll just say racing brand X, whatever. And he uses that as his points. He puts marks on it, and then when he goes and he sets the timing, I've had his engines 16, 20. The other day was 39 degrees off from what factory showed. Yep. And I had to go diagnose with spark plug holes and do a bunch of stuff to make that accurate. And lo and behold, nothing was right. His weren't right, factory wasn't right. It was somewhere in the middle, and it was just the most frustrating cartoon. So it's very important to do that.
I've dealt with engines where the owners unknowingly go between S4 and S5 on the rotaries, and those don't line up identical.
That's exactly what happened.
You also get, for example, let's say, hey, I put an FFE on there, but there's absolutely no zero or marks at all.
They're always printed on the front cover, whether it's a black diamond or their logo or whatever, and it'll align with the sensor. If it's a diamond, it's going to align with the crank sensor itself.
But that's not how you're used to, because the factory has a pointer on top of here, but that's not your zero anymore.
Instructions are important. Let's leave it at that.
RTFM, yes.
We'll catch you guys in the next video. Hope you guys enjoyed this one. Plenty more to come.
We're probably not done with